Welcome back to PCTE Industrial NDT, where we're showcasing the range of Doppler equipment that PCTE is the national distributor here both in Australia and also in New Zealand. So what we'd like to focus on in this episode is a corrosion scanner. This tool is used for mapping and determining the amount of corrosion, whether it be in pipes. You can do it circumferentially or you can do it longitudinally as the application dictates. So how does it go about it? Quite simply, we have a 7.5 meg 64 element probe sitting within a housing, this aluminium housing here, and we then use water to transmit the sound from the crystals into the material. Now we can adjust the water height to make sure we've got sufficient backwall echoes so that we know that we're getting the data that we require. So to do that, basically in this instance we have a chassis that holds the water. We have 4 very strong magnetic wheels that holds the unit in place. So you can imagine if you're going around the pipe, you don't want to be holding it onto the pipe at between the 4 and 8 o'clock position, and it's just a matter of easily scanning that around. Now I can move this back. There's a bit of resistance. Take the brake off. At the back we do have a brake to stop the unit from sliding if need be, to lock it in a certain position. So if you find a defect and you want to hold it there, you can tighten that thumb screw and just apply the brake. Or not too much. And apply the brake. So we have an umbilical cord here that allows both the encoder, the water feed, and also the input from the probe going back to the instrument. The encoder is set on the back axle so that it will give you the relative position from your index point, your start point, to where any defects or suspect defects come up so that you can map that out for your client. What we need to do now is, if I just put some water into the water path, you can see that we have now got our signal and we've got 3 back wall echoes. I've just thrown this probe straight onto this plate. I haven't calibrated it. I haven't done anything other than just trying to get a signal. And by moving it backwards and forwards, we can see that already our signals are interrupted as they flow along on the B scan, and we can then determine that we've either got wall loss, and we can then measure how much of that wall loss is. So on this plate we have tapered slopes, I have drilled holes, they're not flat bottom holes, and I have some gouging just to try and simulate some of the defects we might find in the field. So quite easy, very robust unit, simple, so therefore it's reliable, and once you're out in the field you can collect volumes of data. You need to make sure though that the phased array unit that you're using to receive the data has sufficient memory, because you are picking up a lot of information. 64 elements over a 1 or 2 meter scan, that is a lot of data. If you'd like to know more, please go onto our website. That's industrial-ndt.com.au. You will be able to get more information or download information from there, or you'll be able to find out who your state manager is, sales manager in your state, to be able to contact to ask about more information or a demonstration. Thank you for watching.